This is 4.6. This is going to be something that's a little bit new to you. I don't think you got this in Algebra 1. We were talking about complex numbers, also known as imaginary numbers. So just going through some terminology here. We're going to say the imaginary unit I is defined as I equals the square root of -1. From anything that you've done previously, you should know that if you were to try and plug a square root of a negative number into a calculator, it's going to give you an error. What we do is we call that an imaginary number. Anytime there's a negative underneath a square root, that's considered an imaginary number. A complex number is a number a plus bi, where a and b are real numbers, so like 5 plus 2i. If b is not equal to 0, then a plus bi is considered an imaginary number. And then the last one we're going to talk about is complex conjugates. So in the last section we talked about conjugates. Complex conjugates are the exact same thing, except they deal with imaginary numbers instead. And we're not going to talk about these last two. So let's just kind of get right into imaginary numbers. So what we need to understand is that I is equal to the square root of -1. That's the most important thing. So if we were going to say have the square root of -2, what we do is anytime we pull a negative out of a square root, it just replaces that negative with an I on the outside. So this would be like saying I times the square root of 2. Okay, so that's what these are equal to each other. So let's talk about I squared, I to the third power, I to the fourth power. This is important. So in this first one we have I squared. What is this equal to? Well, this is equal to the square root of -1 times the square root of -1. And we have talked about in the past that two square roots of the same number multiplied by each other will cancel out the square roots. So I squared is equal to -1. So now we want to know what I to the third is. Well, if you understand anything about exponents, I squared times I is the same thing as I to the third. So therefore we can take -1 and multiply it by the square root of -1, because that's what I is equal to. -1 is I squared, and that equals negative square root of -1. We go to the, I to the fourth. We can do that a couple different ways. We can either take what we have here, or we could just say I squared times I squared, which is -1 times -1. That's a positive 1. Then we go to I to the fifth, and what you should see is the cycle starts all over again. We have I to the fourth times I, so we just have 1 times the square root of -1, so it's just square root of -1 again. And that, notice that's what I to the first power is. So I to the sixth power should be exactly the same as I to the second power, and it is. I to the fourth times I squared. I to the fourth is 1 times I squared is -1, so we're back to -1. So what does this mean for solving equations? Well, what we're going to do is let's see what happens. So this is going to be very similar to what we did in 4.5. We're going to solve the equation as normal, and we're going to try and get our x squared by itself. So we have 3x squared equals -24. We divide both sides by 3, and we get x squared equals -8. We take the square root of both sides. We get x equals plus or minus the square root of -8. And here's where our problem is, because we now have a negative underneath the square root. So what we do is we continue on with this, and we say we want to pull the negative out. So we have x equals plus or minus I times the square root of 8. So we pulled the negative out to the outside, it becomes I. And now the only thing left to do is to reduce our radical. So I times the square root of 4 times the square root of 2. So x equals, the square root of 4 is 2. So x equals plus or minus 2I times the square root of 2. So notice I did bring the whole number in front of the I, and I left the square root at the end. So whole numbers go in front of I just like if it was a variable. But either way, you should have something, or you should see something very similar to this. Okay, why don't you guys try this one on your own? Put your answer in, and we'll see how close you get. So hopefully, solving this equation, you got down to x squared equals negative 6, which ends up being x equals plus or minus I times the square root of 6. Okay, moving on. To me, this is the easier part of the section. So here we're talking about how to combine like terms. Keep in mind that I is exactly like a variable, so everything works exactly the same. Whether you're adding, subtracting, multiplying, it all works the same as if it was a variable. So when we're adding these, we have 9 plus a negative 6 is a positive 3, negative I plus a positive 7I is a positive 6I, and that is done. Down here for multiplication, same thing. We FOIL just as we normally would. Negative 2 times negative 1 is positive 2. Negative 2 times 4i is negative 8i. 5i times negative 1 is negative 5i. And then 5i times 4i is 20i squared. So now we combine like terms. 2 minus 13i plus 20. And now we need to make our I squared a negative 1. So this is going to be a negative 20 here. So 2 plus a negative 20. So 2 minus 20 is negative 18 minus 13i. And that's what we end up with there. Okay, I want you to try these two on your own. A subtraction problem and another multiplication problem. And then put your answers in that puzzle. For the first one, 3 minus 8 is negative 5. 7 minus a negative 2 is a positive 9. So the big mistake made here is forgetting that we have two negatives here. So it would be 7 plus 2, which is 9i. Down below, we have, we FOIL, we get 64 plus 24i minus 24i. Those cancel out. Minus 9i squared. That 9 times negative 1 becomes a positive 9, so you should get 73. Okay, moving on down to the next set of examples. So this is probably where the hardest part comes in, and this is where we're dividing complex numbers, because in reality, when you have complex numbers on the bottom of a fraction, we still have to get rid of them. We have to rationalize the denominator. We can't have imaginary numbers because those are technically square roots on the bottom of a fraction. So what we need to do is, it's very similar to what we did in section 4.5, where we had to rationalize the denominator using a conjugate. So here we are going to do the exact same thing. If we have a complex number that's added or subtracted on the bottom, or even if it's not, we need to multiply by the conjugate. So in this case, you have an example here. So we had 1 minus 4i on the bottom. We multiply that by 1 plus 4i on both top and bottom, and then simplify from there. So you had to FOIL on top, FOIL on the bottom, and then that will get rid of our I on the bottom in every single case. So let's see how that works with this problem right here. So we have 1 plus I on the bottom, so therefore we need to multiply by 1 minus I on top and bottom. So that leaves us with 5 minus 5i on top. And on the bottom, we have 1 times 1 is 1. And remember, multiplying by the conjugate, the whole point of it is to get rid of our middle terms. So that means we'd have minus I plus I minus I squared. So the middle two terms cancel out. So we're left with 5 minus 5i on top, and 1 minus a negative 1, which is 2. And then what you also want to make sure you're doing is simplifying or breaking this up into a real part and an imaginary part. And that's what our answer ends up being. Okay, once again, try this one on your own. See how this goes. Hopefully it's going okay. So here, when we multiply by the conjugate, you should have done 3 plus I over 3 plus I, getting what we get on top. Going through the simplification process, you should have had 18i minus 6 over 10. We separate that. We divide everything by 2 to simplify. 9i over 5 minus 3 over 5. And then whenever you write out a complex or an imaginary number, you should always put the real part first and the imaginary part second. So you see, I just moved this term right here out front, negative 3/5, and then plus 9i over 5. Okay, so that's it for this section. I will see you in class, and again, bring questions if there's something that didn't make sense.